Okay, so we will look into this paper February, March 2025. Okay, so question number 1, okay, Boltzmann's distribution of a reacting gas is shown. Okay, so if which point could you show the number of particles whose energy is the same as the activation energy at the new temperature? Okay, so here they say that the temperature is going to be decreased. Okay, when the temperature is decreased, the Boltzmann's distribution will look like something like this. Okay, we can maybe get something like this. And then, when the temperature is decreased, temperature decrease, they will go up. Okay, then they will be somewhere here, And then we know that activation energy is from here, therefore, they ask which point shows the number of particles whose energy is the same as the activation energy with the new temperature, so it should be at D, So number 1, the answer is D. Now, for question number 2, crystal copper nitrate are prepared by adding excess, malachite to nitric acid. So this is going to be, the malachite. So what we need to do over here is we need to write the equation for copper hydroxide, reacting with HNO3. So you have this, The equations are written over there, balance as well. And then you write the equation for copper carbonate, balance as well here. And what we are going to do, we combine these two equations together, and you will get a combined equation something like this. And we notice that 1 mole of this will react with 1 mole of this, with 4 moles of this to give you 2 moles, 3 moles, and 1 mole. So what we can do now is we need to find out the number of moles of nitric acid. The nitric acid number of moles you can get from 30 times 1.5 divided by 1000 is going to be 0.045 moles. And we can, from here we can find out the number of moles which is for this malachite, which is going to be together. If you put it together, this 1 will not become 2, it will be also going to be 1 mole itself. So that 1 mole, we want to find out what is 1 mole, because 4 moles, so you divide by 4, you will get this number of moles. So it means now we know that the number of moles of malachite is going to be 0.01125. So we can find out the mass of malachite, which is going to be using the MR over here. Number of moles equals to mass over MR. Mass is going to be, we just need to times these two. So 0.01125, when you times with 221, we will get the mass. If you calculate this, you will get if you calculate 2.486, so let's say 2.49. If you have 2.49, you can find out the mass, which is left unreacted because you use 12 gram. 12 minus 2.49, you will get the answer, which is going to be 9.51. That is going to be the answer. So no need to find out the individual mass of copper carbonate and copper hydroxide if you are calculating them together. But if you want to calculate using the long way, you can actually find out 1 mole of this, 1 mole of this, find out the mass of this, find out the mass of this. The total of these two mass will give you the 2.48625. Then you still use the same method. 12 minus 2.49, you will still get 9.51. Number 3. Now X and Y are elements from the same group of the periodic table. The 5th to 9th ionization energy are shown. Which row identifies element X and Y? They mention X and Y, they are from the same group. So whatever, let's say for example, if there is a big jump, okay, both X and Y will experience the same big jump as well. Okay, from here we can see the big jump is happening from 7 to 8, and here, okay, it's going to be almost the same from 11,000 to 33,000. Okay, so in this case, we know that the 8th electron, okay, is in the inner shell. Okay, so there should be 7 valence electron. Okay, 7 valence electron. So we are talking about group 17. Okay, group 17. So if we look at group 17, most likely, okay, definitely neon argon will not be there. So now we have element X and Y. In general, if you compare, okay, element X and Y, okay, at the 5th ionization energy, even from the beginning itself, okay, element X, okay, they have higher ionization energy compared to element Y. Okay, so generally, okay, if you are, okay, Cl and fluorine is at the top. Fluorine, okay, supposed to be having the greater ionization energy if you compare with chlorine, okay, because they have less shielding effect, okay, less shielding effect, and they supposed to be having greater attraction towards the electrons, making it difficult to remove. Okay, so therefore, okay, X should be, okay, fluorine. Okay, but so if you look over there, fluorine, okay, chlorine, so you see chlorine is below, so ionization energy is supposed to be lower. So Y is chlorine, this one is F, so the answer is going to be C. Now, question number 4. Ion, okay, with a charge of 2 minus, okay, contain 10 electrons and 14 neutrons. What is the nuclear number? Okay, if you have X with a charge of 2 minus, okay, if you have 10 electrons, okay, it means that they have included the 2 electrons. It means the number of protons should be only 8, because number of electron and proton should be the same. Okay, so you minus the 2 over there, so you have 8 electrons, so 8 electrons is 8 proton. Okay, and then you have 14 neutrons, so you just need to add 14, so that's going to be 22. So they just want us to find out what is the nuclear number. Okay, the nuclear number in this case is going to be 22. Okay, so 4 is B. Now, number 5, okay, histamine, okay, and then we have the bond angles over there. Always remember nitrogen is going to be group 15. They have 5 valence electron. So do remember that they have the lone pair over there. Okay, carbon don't have the lone pair. Okay, and then here you can see the structure itself. Do not use, okay, the shape drawn over there and deduce the shape. The bond is like that. Like for example, do not just simply say, oh, this is going to be 120. This is looks like 90 degrees. Then it's going to be 90. No, you don't determine using that. If you have X, okay, you have 3 bonding pair and 1 lone pair. The X bond supposed to be following the bond angle for pyramidal. Okay, pyramidal is going to be 107 degrees. Okay, so X is 107 degrees. Y is going to be 4 bonding pair. So they must be 109.5 degrees, tetrahedral. And here, okay, if you look over here, okay, there is going to be 3 sigma bond. Okay, ignore the pi bond. 3 sigma bond is going to be 3 bonding pair, no lone pair. Therefore, Z is going to be 120 degrees. So if they want you to arrange, okay, from smallest to largest, supposed to be X, Y, and Z. Okay, X, Y, and Z. The answer is going to be A. Now, number 6. Okay, number 6, when organic acid, okay, reacts with an alcohol, okay, reversible reaction is taking place. Like for example, if I have carboxylic acid reacting with alcohol, we know 1 mole of water will come out. Okay, so generally we are looking into 1 mole, 1 mole, 1 mole, 1 mole. Therefore, organic acid reacting with alcohol, okay, to give you 1 mole of ester, 1 mole of water. Okay, so I can use the ice method, initial, change, and equilibrium. Okay, so initially, okay, we have 0.4 moles of organic acid, 0.3. We don't have any ester and water. And then at equilibrium, they say 0.20 moles of ester is there. So it means the change is plus 0.20. So since all of them are 1 mole, okay, the changes must be following the same. Plus 0.20. These are reactants, so minus 0.20, minus 0.20. At equilibrium, you will get all these values. Okay. So if we follow the Kc, Kc is ester, concentration of ester, times concentration of water divided by concentration of organic acid, concentration of alcohol. Okay, no to the power of something. Okay, it's all power of 1. Why? Because all of them are going to be 1 mole. Right? So all this is 1. Okay, so here, okay, we will include water. Please remember, do not remove water. Okay, so you will have, okay, 0.20 divided by volume, divide by volume. All this volume will cancel off. Okay, why divide by volume? Because it's concentration. Okay, just now we use number of moles. Okay, so concentration V will go on, and then you have 0.2 times 0.2, 0.2 times 0.1, cancel. 0.2 divided by 0.1 is 2. So therefore, the answer is going to be 2. That's the value of Kc. Now, next question, question number 7. Okay, substance P and Q. Okay, electrical conductivity, good when solid and molten. Please remember, ionic compounds do not conduct electricity when they are solid. So if something is conducting electricity when they are solid, most likely they are metals. Okay, so effect of adding water, produce vigorous, okay, react rigorously to produce alkaline solution. Most likely this is going to be group 1 or group 2 metals. Yeah, so melting point is quite high. Okay, most likely also again might be metal. Okay, so Q does not conduct electricity in any state, so must be anything that is covalent. Okay, so non-metal and non-metal, okay, react vigorously to produce an acidic solution. Okay, so this one must be definitely going to be some kind of a compound that has near the non-metal. Yeah, the non-metal. Okay, and then the melting point is given. So if we look over here, P, if I say metal, metal will be always giant metallic. Okay, so definitely B and C will not be our answer. Okay, but okay, we will not select giant ionic for Q because giant ionic will still conduct electricity when they are molten. Okay, so therefore, okay, D cannot be giant ionic. It must be simple molecular. Another reason why it's simple molecular, because does not conduct electricity in any state, and then also react vigorously to produce acidic solution. This is going to be hydrolyzed. Okay, hydrolyzed, and then the melting point is comparatively is slightly lower. Okay, when the wall forces are going to be smaller. Therefore, the answer for this is going to be A. Now, excess, okay, of zinc, okay, reacts with X cm cube of hydrochloric acid. Okay, so zinc plus HCl, they will give you zinc chloride plus hydrogen gas. So this one should be half. Then after that, this one is 2. Okay, so hydrogen, okay, hydrogen is going to be 2, Cl is 2, so I think it's balanced. Zinc plus 2 HCl to give you zinc chloride plus hydrogen gas. Okay, now they say that the gas produced, which is the hydrogen gas, okay, it is going to be dried and collected. The gas occupies all these conditions. Okay, it behaves as an ideal gas. We want to find what is X. So PV equals to nRT. Okay, so pressure, okay, in this case use 101 0, okay, volume, okay, change into meter cube. How to change? 1.534. D is 10 negative 1. There are 10 negative 1, 10 negative 1, 10 negative 1, okay, meter cube. Okay, so it's going to be 1.534 times 10 negative 3. Okay, N, okay, RT is going to be 8.31. Temperature is 293. Okay, someone help me to calculate this. N is, okay, this one 10 negative 3 is 101 times 1.534 divided by 8.31 times 293. What is N? What is the number of moles? Help me, William. Okay, number of moles. Once you have the number of moles, okay, number of moles equals to 0.6363. Okay, this is the number of moles of hydrogen. So do remember 0.06363. One of the common mistakes that students will do is they just use the same number of moles and then try to find out the X. Cannot, because 1 mole is 2 moles over here. So it means that you need to times by 2 over here. So 2 times 0.06363. Okay, 2 times 0.06363. That number of moles, okay, is equivalent to this, okay, which is going to be X times 2 divided by 1000. Okay, you just need to find X. 2 and 2 will cancel. Okay, times by 1000, 1, 2, 3, 63.63. Okay, so the answer is going to be C. Okay, number 9, an aqueous solution of hydrogen peroxide is placed in a flask and decomposes as shown. The total volume of oxygen gas given out, okay, is 180 cm cube after 90 seconds measured at room condition. The rate of the reaction is calculated using the equation shown. Change in moles, okay, of H2O2 divided by time. Okay. What is the average rate of the reaction measured in mole per minute, okay, over the duration of this? Okay, first of all, just to be careful, okay, 90 seconds is 1.5 minute. Okay, so later we will use divided by 1.5. First, find out what is the change in moles of H2O2. Find out the number of moles of oxygen that is going to be produced first. So we know that 1 mole will give 24 dm cube, which is going to be 24,000, okay, cm cube. So 1 cm cube is 1 divided by 24,000. You are looking for 180 cm cube. 180 cm cube is going to be 1 over 24,000 times 180. How many moles is that? Help me. Okay, that is going to be number of moles. Okay, so what we do over here, we know that you are producing 7.5 times 10 negative 3, but we are looking into change of moles. If this is being produced, this is going to be minus. Okay, minus how much? Okay, double. Okay, double, so it's going to be 2 times 7.5 5 times 10 to the power negative 3, which is going to be 15. Okay, 15 times 10 negative 3. Okay, this one you can just put 1.5 times 10 negative 2. Okay, now in this case, okay, I just need to put 1.5 times 10 negative 2 over here. No need to put negative because we know the change is decreasing. Yeah, no need to put. Okay, so this one divided by this is going to be 1 times 10 negative 2. Okay, so 10 negative 2, 1 to 0.01. Okay, the answer should be D, mole per minute. Okay, so make sure the answer you get in D. Yeah. Okay, let's look at question number 10. Okay, for question number 10, methanol is manufactured, okay, using the following reaction. Okay, what increases the equilibrium yield of methanol in this process? So you want to produce more methanol. How can you do that? Okay, in terms of heat, temperature, so we know the negative. Okay, you put your hand over there. This is going to be hot. Here is going to be cold. So if you decrease the temperature, temperature should go up according to LCP. Okay, so in order to go up, it will go from cold to hot. So in this case, we have to decrease the temperature. Okay, so this is wrong. Okay, and then related to equilibrium yield, okay, adding a catalyst will not change the equilibrium yield. Okay, let's look at other factors. Okay, all of them are gas. So 1 mole, 3 mole, total 4 moles. Okay, 1 mole and 1 mole, total 2 moles. So if you increase the pressure according to LCP, you need to decrease the pressure. How do you decrease the pressure? By moving from more number of moles to less number of moles. So therefore, in this case, it is going to be shifted to the right, okay, to form less moles of molecules. Okay, therefore this is going to increase the yield because it's going to the right. Okay, adding excess of steam will not be the answer because excess of steam, it will actually move the position of the equilibrium to the left. So the answer is A. Now number 11, okay, the equation for the reaction, okay, KClO3 is given. Which one is correct? So we want to find out, okay, whether it's a disproportionation reaction or not. Okay, let's actually look at oxidation number. Okay, so first let's calculate the oxidation number of this. So K is +1. Okay, so +1, Cl is X. Then 3 times -2 equals to 0. So 1 plus X minus 6. Okay, X minus 5. Okay, X equals to +5. So this is +5. So here, okay, Cl is -1. Here, okay, K is +1. Okay, X 4 times -2 equals to 0. X minus 8, so -7 equals to 0. X equals to +7. So this is +7. And we know here, okay, from +5 to -1 reduction, +5 to +7 is going to be oxidation. Therefore it is a disproportionation reaction. It's a reaction where KCl is going to be oxidized and reduced at the same time. Oxidation number, okay, is going to be, in this case we found out it's going to be 7. Therefore the answer is going to be B. Okay, now number 12, okay, this one is going to be a student mixes, okay, sodium hydroxide with hydrochloric acid. So I have written the equation over there. Okay, so once you have the equation, okay, we know that we can calculate the number of moles. Okay, how do we calculate the number of moles? 25 times 0.1 divided by 1000. Okay, so number of moles equals to 25 times 0.1 divided by 1000. So that's going to be 2.5. If you want to bring it up, -3. So number of moles. And then the student record the rise of 2.5 degrees Celsius. So that is delta T, the temperature increase. Yeah, no need to change it to Kelvin. Yeah, that's the increase. So if you want to calculate this, Q equals to MC delta T. And then M, okay, is the mass of water. Okay, so the mass of water is 25 plus 25. They are total 100 cm cube. So it's going to be 50 grams. So we will use that. this is going to be heat capacity, so of water, so 4.18, and then put the 2.5, and you will get, okay, 525.5. Now this 525.5, we know that because that's going to be temperature increase, it's going to be exothermic reaction, okay, and then this is for 2.5 times 10 negative 3 moles of sodium hydroxide. So you want it for 1 mole, so what we need to do, 1 mole is this value, okay, divided by this, okay, so negative 525.5 is joule, you need to change it into kilojoule, so divide by 1000, so you will get 10 to the power negative 3 divided by 2.5 times 10 negative 3, this one cancel and this one you cancel. So in the end, okay, when we calculate this, okay, this one bring it over here, so you will get, okay, 209, but it is negative, please take note, 209 kilojoule per mole. The answer is going to be A in this case, okay. Now number 13, okay, we know that carbon monoxide and methanol can react together to form ethanoic acid. So first, write the equation CO, okay, reacting with oxygen, you get this 1 mole of CO, heat or enthalpy change of combustion, and then you write the equation, and then the same thing, you do the same thing over here. I have written the equations over there, and then the third one we put over there. The trick for this question is we need to rearrange it. Actually, no need to calculate or something like that, we just need to rearrange. Okay, and then all the number of moles and so on will align accordingly. You just need to check here is on the right hand side. So here we have this on the left hand side. We need to change the position. So if you change the position, okay, this one earlier was negative, so now it will become positive because we changed the position, okay, and it's also 1 mole, no need to times with anything. But the rest, okay, CO is still here, so we will not change the position, we will use the equation as it is, okay, and if you write the equation, then it's going to be still going to be negative 283, and then this, okay, similar is on the left, and here is on the left, so we will use the same thing, okay, and we keep it over there. So what we need to do is just need to add all this together, okay, 874.1 plus negative, so it become negative, and then plus negative 283 means minus. So if you calculate this, okay, we know that this is going to be like already 1000 something. So if you calculate this, you will get a negative value, okay, the negative value is going to be this. So the answer for this is going to be B. Now 14, copper reacts with nitric acid under certain condition, okay. The products are copper 2 nitrate, water, and oxide of nitrogen. So copper react with HNO3, okay, it's going to give you copper 2 nitrate, so this plus water, okay, and then an oxide of nitrogen, so we don't know, okay, a type of oxide, okay, okay. Now they say that, okay, 3 moles of copper, okay, reacts with, okay, exactly 8 moles of nitric acid. So 3 moles of copper reacting with 8 moles of nitric acid, okay, what is the oxidation state? So if you use copper, if you use 3 moles, must be 3 over here, all the copper are there, okay. And here when I have hydrogen, okay, all the hydrogen is coming from water, okay. So if I have 8 moles of hydrogen, so this one must be 4, okay. So if I calculate over here, okay, the number of oxygen on my left hand side is going to be 8 times 3, okay, which is going to be 24. The number of oxygen here is going to be 3 times 2 is 6, 6 times 3 is going to be 18. And then the number of oxygen here is going to be 4, okay. So total is going to be 22. So we need 2 more oxygen, so we will just put 2 there. And then the nitrogen, okay, when we calculate here, okay, we know the nitrogen, we have 2 nitrogen here, and then I put 3, so total is going to be 2 times 3, 6. 6 nitrogen is there. Okay, so we need 8 nitrogen. Okay, so in order to have that 8 nitrogen, okay, so let's calculate again. 2 nitrogen, okay, 2 nitrogen, and then 3, so it's going to be 6 nitrogen. So we need 8 nitrogen, so nitrogen must be 2, so it must be N2O2. Okay, so it will be something like this. Okay, so N2O2, or okay, if let's say we want to write down 2 over here, cannot be 2 because we already put 2 there. Okay, so it can be either 2NO, okay, or it can be N2O2, something like this. Okay, so what is the oxidation state in the oxide that is being produced? Okay, if we follow the number 2 outside, okay, then the X will be, this is -2, so this one must be +2. Okay, +2. If we do like this, okay, let's try only. Okay, 2x minus 4 equals to 0, 2x equals to 4, x equals to 4 divided by 2 is also going to be 2. So in the end, we are still getting the 2 over there. So the answer is going to be B. All the reactant and products of an exothermic reaction are gases. Which statement about this is correct? So if we look at the delta H is going to be negative. Yeah, exothermic must be, delta H must be negative. So this one will be wrong. And then we know that, okay, when we look into bond breaking and bond formation, so bond breaking is going to be for the reactant, bond formation is going to be for the products. Okay, so in order to get a negative value, because we know the bond formation is negative value, this one is going to be positive value. When can we get more negative value? Is when you add these two. Okay, when we add these two, if this value, okay, is going to be greater, the value, yeah, negative value is greater, definitely we will have the delta H which is going to be negative. Okay, so in this case, the product must have a greater bond energy. Okay, greater bond energy, the value must be greater. So the total bond energy should be more, okay, than the total bond energy of the reactant. So the answer is going to be C. Now for 16, propene, okay, hydrogen cyanide and carbon dioxide each contains pi bonds. Okay, which molecules contain two pi bonds? Okay, so if you want 2 pi bonds, carbon dioxide, okay, each contain pi bonds. Okay, which one? 2 pi bonds. Propene, okay, this is going to be propene. Okay, hydrogen cyanide is going to be written in this way, and carbon dioxide is written in this way. So we can clearly see over here there is pi bond here, pi bond here, so 2 pi. Okay, there is pi bond here, pi bond here, 1 sigma here. Okay, sigma, sigma. Okay, so this one is 1 pi and 1 sigma over there. Okay, so in this case, if we are looking for 2 pi bonds, okay, we are looking into hydrogen cyanide and carbon dioxide. Okay, so the answer is going to be A. Now 17. Q, R, and S are consecutive elements in period 3 of the periodic table. Element R has the highest first ionization energy and the lowest melting point of these 3 elements. Okay, so if we are looking into highest first ionization energy, so we know that the size, okay, the atomic radius becomes smaller as you go across the periodic table. So if we are looking into highest first ionization energy, must be something that is located towards the right hand side of the periodic table. Okay, so if we follow here, sodium, magnesium, aluminium, possible. Okay, magnesium, aluminium, silicon, okay, possible. Okay, because they say that S, okay, is supposed to be the most to the right. Yes, to the right. I think all follows the trend. Okay, so here, okay, they say they say element R has the highest, okay, highest first ionization energy. Okay, so it means that element R, okay, must be to the compared to the rest, okay, must be on the right hand side. Okay, so if we look over here, maybe hold on first here. Okay, let's look at sodium, magnesium, aluminium, okay, silicon, phosphorus, sulfur, okay. So if let's say for example this is going to be 1s neon, okay, neon 3s1, okay, 3s2, 3s1, 3s1, 3s2, sorry, this is 3s2, this will be neon 3s2, 3p1, okay, 3p2, 3p3, 3p4, okay. Now here, okay, if I compare, okay, are going to be the highest, okay, first ionization energy. Magnesium, okay, magnesium, if I compare with aluminium, okay, the highest, okay, should be, okay, aluminium, because it is, okay, 3s2, so aluminium 3p1, because slightly further away, okay, it's going to be much more easier to remove for aluminium, okay, the electrons, okay, the one electron over here, okay, compared to magnesium over here. So maybe in this case, okay, R can be magnesium, okay. Let's hold on first. Then for B, okay, magnesium, aluminium and silicon, okay, definitely if we go across, silicon should be over here, okay, but it's easier to remove, should be easier to remove over here, then silicon should be there, so should not be the answer. Okay, aluminium, silicon and phosphorus, okay, easy to remove, difficult, so we know that it's going there. I think most likely this one, silicon, phosphorus and sulfur. Okay, this one we check, okay, 3p4, okay, I think 3p4 related to sulfur. They may have this we have 3s2, 3p4, okay, they may have the spin pair repulsion, okay. So because it's like this, 1, 2, 3 and 4, okay, it's possible to have spin pair repulsion. Now, so in this case it's going to be easier to remove this, okay. So phosphorus might be the R over here, okay, the rest should be okay. So now let's look into the lowest melting point, okay. Lowest melting point is going to be R, okay. So definitely, okay, lowest melting point, aluminium magnesium cannot be the lowest melting point, it should be sodium, so definitely wrong, okay. And then if we look at here, okay, lowest melting point is silicon. Silicon, normally the lowest melting point, okay, because silicon is going to have a giant structure, okay. Phosphorus is going to be simple molecular, okay, so therefore might not be the answer, okay. So if lowest in here phosphorus, and then sulfur, okay, is slightly bigger, okay, so it's going to be phosphorus might be the lowest. So in this case, okay, the best answer that I can see over here, 17, is going to be D, okay. So D, okay, if you look at the highest first ionization energy, okay, it's going to be phosphorus, okay, because they are far away over here, okay. But why not sulfur? Okay, because of the spin pair repulsion, okay. So in this case, the lowest, okay, the highest first ionization energy is going to be phosphorus, not sulfur, yeah, because sulfur has spin pair repulsion, okay. And then we selected, okay, silicon is going to be highest melting point, okay. The lowest melting point will come to P, because P4, okay, and S8. P4 is smaller than S8, okay, because this has more van der Waals forces. So the answer is going to be D. Scheme for group 2 metal is shown, okay. So you have, okay, M reacting with oxygen, okay, supposed to give you magnesium oxide. or magnesium oxide reacting with water. You should know that magnesium oxide reacting with water will give you magnesium hydroxide, okay? But do remember if, let's say, magnesium alone, okay? Magnesium alone reacting with water, okay? This is extra thing that we are going to learn, yeah? So if it is going to be, the water is going to be cold, okay, and the water is going to be hot, okay? If it is hot, you will get magnesium oxide, okay? If it is cold, it's magnesium hydroxide. Do remember, they will give you hydrogen gas. It will give you hydrogen gas. This is only for magnesium, okay? But the rest of it, okay, below group 2, okay, they are going to react with water, okay? No need hot or cold. They will follow the cold version, which is going to be, they will give you hydroxide, okay? In this case, magnesium oxide, of course, it will give you magnesium hydroxide. And then when it reacts with magnesium hydroxide, react with sulfuric acid, they will give you magnesium sulfate, okay? Now, here they are asking the solubility of X, okay? Solubility of Y. Y is hydroxide. Going down the group, okay? Solubility of hydroxide supposed to increase, okay? You should know this. And solubility of Z, which is going to be sulfate. Going down the group, like especially you should know that barium sulfate is white solid, okay? Therefore, okay, since you have the precipitate which is white, okay, it means that going down the group, okay, it means the solubility decreases. So the answer is going to be C for this, 18, yeah? Now, in 19, U, V, and W represents different halogens. The table shows the result of 9 experiments containing all this. They were separately added, okay, into separate solutions and so on. Okay, which row contains the ion in order of decreasing strength as reducing agent? Okay, let's look at it first, yeah. Now, when we say reducing agent is something that will reduce others, but they themselves will get oxidized. So what is the meaning of oxidation? Oil rig, okay? Oxidation is loss of electron. So they themselves will lose the electron, okay? They will lose electron. Now, when they say decreasing strength, okay, decreasing strength, it means that here, okay, they are going to lose electron, okay? Here also going to lose electron, okay? But which one will actually lose electron more? Like, for example, strong reducing agent lose electron more, okay? Lose electron less, okay? We want to find out that, okay? We want to find out that. Now we analyze the table, okay? Now, we know, like for example, okay, if I have Cl, Cbi, yeah, chlorine, bromine, iodine, okay, we know that, okay, the one on top, okay, will displace the one below, okay. For example, if I have Cl2, yeah, Cl2 with NaBr, for example, okay, there will be a reaction. Why? Because Cl is actually on top of bromine. Okay, so it means that you are going to have Br2 plus NaCl. That is what I mean. So if I have Cl2 plus NaI, for example, because Cl2 is on top of I, so they are going to have I2 plus NaCl. But if you are reacting Cl2, okay, with NaCl, no reaction. Okay, but let's look at Br2, yeah. Now Br2, okay, when they react with NaI, there is reaction, I2 plus NaBr, displacement can happen, okay? But if you react Br2 with NaCl, for example, because Cl is on top, okay? So they are not going to have any reaction. That's the meaning, okay? Now let's look at, okay, U2, yeah? Now U2, okay, when you react with this, no reaction, no reaction, no reaction. It means that, okay, U2 should be at the bottom. Okay, if you have the lace, U2 should be at the bottom. Now, let's look at V2. Okay, V2 is going to be, you see here, can displace U. So it means that V2 should be higher than U2. Okay, no reaction, but there is also W also. So it means that V2, okay, should be also higher than W. So it means W should be in the middle lah. Okay, so I'm assuming V2, W2, U2. Okay, let's confirm that in the last one. When you use W2, okay, you are going to displace U, which is correct. Okay, no reaction, no reaction. Okay, when V, okay, no reaction. Okay, when you react with W, no reaction, which is matching with what we have now. Okay, it means now, okay, I want to check, okay, like for example, if you have V2, W2, and U2, okay, it means that it is similar, okay, or equivalent to CBI. Okay, it is equivalent to CBI. Let's say I assume. Okay, now if now I take it as CL minus, BR minus, and I minus. Okay, this is going to be V minus, W minus, U minus. Okay, it's similar. Okay, it's equivalent. Okay, now I want to know ability to lose electron. Okay, ability to lose electron. So you see here, okay, we know that, okay, CL is small, BR and I. Okay, so generally, if you have the extra one electron, they will still follow this arrangement. Okay, so CL, okay, CL minus, BR minus, I minus. Because the distance, okay, is from the top to lower, okay, the distance from the nucleus to the electron is a lot, going away from the nucleus, and also because of the shielding effect, it means that it is going to be difficult. We are looking into losing electron, so it's going to be easier for this electron to lose, okay, because of shielding effect. Okay, they are going to be held less strongly. It means that I minus is easier to lose, okay, compared to Cl minus. It means if I convert this, I want to lose electron more, it must be U minus followed by W minus followed by V minus. Okay, so the answer for number 19, okay, is going to be boy. Okay, it will be better or easier for you to represent using CL, BR, and I for this question. Okay, if you fail to represent, I think it's going to be more difficult for you to understand. Okay, so the concept must be strong. Okay, so I have explained to you already. Now let's look at question 20. Okay, now J is either, okay, magnesium chloride or aluminium chloride. K is either this. Okay, so when I add, okay, J can be magnesium chloride, can be aluminium chloride. Okay, when I add, okay, aqueous sodium hydroxide, I am going to get a white precipitate. Okay, so magnesium chloride, okay, when I add sodium hydroxide, okay, you are going magnesium chloride, okay, when I add sodium hydroxide, okay, I'm getting magnesium hydroxide, okay, and then I'm getting NaCl. Possible, okay, to get white precipitate from magnesium hydroxide. Okay, if you are looking into sodium chloride is colorless. Okay, if aluminium chloride, okay, when I react with sodium hydroxide, I am going to get, okay, aluminium hydroxide, okay, aluminium hydroxide and sodium chloride. So this one also possible white precipitate. Okay, now when you take this hydroxide, okay, when you add excess, okay, when you add excess, they say the precipitate dissolves. Okay, so when you add excess, precipitate dissolve. Okay, so in this case, okay, if I look into sodium hydroxide, when I add excess, precipitate dissolve. This one need to wait for a while, because when you add excess, okay, maybe it can be also additional of water. Okay, if you have water, I know that aluminium hydroxide can dissolve, okay? But let's look at K first, okay? Let's look at K. K is going to be SiO2 and SiCl4. When you add water, misty white fume and a white precipitate, okay, in a solution with pH less than 7. Now both of them, okay, will give you acidic, okay, when you add water. Can you double check SiO2 when you add water, what will you get? SiO2 plus water, SiCl4 plus water, what will you get? This one I know you will get SiO2 plus HCl, okay? How about SiO2 plus H2O? Z, can you check the notes? SiO2? No reaction, yeah? Because it's going to be a big molecule, okay? So no reaction. So most likely now, okay, SiO2 and HCl, and they say misty white fume. HCl is a misty white fume. White precipitate in solution, pH less than 7, which is correct, yeah? So in this case, we fix the identity of K as SiCl4. Now, the only issue over here, we need to find out whether the identity of J is it aluminum chloride or magnesium chloride. Now, magnesium chloride, okay, magnesium hydroxide, we know that hydroxide going down the group, okay, they are going to be more soluble. So it means that at the top, okay, hydroxide, magnesium hydroxide is going to be less soluble. So knowing that fact, okay, I know magnesium hydroxide may be not soluble, okay, but I know that aluminium hydroxide should be more soluble than because hydroxide, okay, when you keep on adding water, they can actually form aluminium ion and OH minus ion. So I'm going to go for this as the answer, okay. So let's check 20, the answer is going to be A, okay. So you decide, okay, you have to decide, okay, this one, okay, you need to memorize the reaction, okay, or take the most accurate guess when you're doing the paper itself. Now, the river water in agricultural area contains the following ions. This water is treated by adding a calculated quantity of calcium hydroxide. Now, what is precipitated from the river water when calcium hydroxide is added? Okay, so when you add calcium hydroxide, okay, so basically you are going to have calcium ion, OH minus ion. Okay, let's check. Calcium do not react with this. Okay, you will have calcium carbonate. Okay, calcium carbonate. You can have calcium hydrogen carbonate. Okay, you can have calcium chloride. You can have calcium nitrate. If you are using OH minus, okay, you will have ammonium hydroxide. Okay, this one do not react. Negative ion, do not react, do not react, do not react. Now, all this from here, we need to find out which one will give you precipitate. Okay, so calcium carbonate, okay, most likely will be the solid over here. They didn't mention anything to do with this. Okay, ignore. Calcium chloride is also there. Okay, calcium nitrate, all nitrate salts, they are soluble. Okay. So you should know that this is soluble, so will not be the answer. Okay, ammonium hydroxide, all ammonium salts are soluble. Okay, this one will not be the answer as well. So you need to choose between calcium carbonate and calcium chloride, and you should know the answer is going to be calcium carbonate. Okay, limestone. Okay, calcium carbonate will be the answer. Calcium chloride is soluble. Now, 4 atmospheric pollutants are listed, okay, nitrogen oxides, carbon monoxide, unburned hydrocarbons, sulfur dioxide. which one, okay, will react, okay, to give you PAN. Okay, please remember this, very popular question currently because they have introduced this in the syllabus, okay. But it's very easy to answer because they didn't ask you to explain. Okay, PAN is formed from nitrogen oxide reacting with unburned hydrocarbons, okay, to give you PAN, which is responsible for photochemical smoke. Photochemical smoke. Okay, so in this case the answer is A. Okay, this one memorize only. Okay, nitrogen oxides can be NO or NO2. Okay, doesn't matter. Now 23, which graph correctly describes the trend found in group 17? Now we are looking into group 17. It means that maybe related to F, okay, Cl2, okay, but here they say CBI, so I'll just remove this, okay, CBI. So if you look at the bond length, okay, we know that generally they are going to become bigger, okay, so the bond length in X2 supposed to become bigger, larger, okay, so cannot. And then the strength of van der Waals forces, because we know more bigger the size, okay, it means more number of electron, more van der Waals forces of attraction. So most likely, okay, correct. Okay, because van der Waals forces is getting more, okay, we know that, okay, the boiling point should be getting bigger. Okay, should not be correct over there. And then the bond energy, we know that the bond length is getting bigger. Okay, the bond energy is supposed to be going down, easier to be broken. So this one is wrong as well. So the answer is going to be B. Now next, 24. Gas M is produced when ammonium chloride reacted with calcium oxide. So ammonium chloride reacted with calcium oxide. Now please take note, okay, if let's say you are not sure, okay, we know that ammonia, okay, ammonia can react with HCl to give you ammonium, okay, ammonium chloride. So I will separate this, okay, you will get this, okay. Now what does it mean? Because ammonia is receiving the H plus from HCl, ammonia is going to be a base, okay, it's a base. Now when they form base, okay, it means that later when you go the other way around, ammonium ion have tendency to lose or give out H plus, okay. So it means that they will become conjugate acid or they can behave an acid. Now why I'm telling you this? Because ammonium ion can become as an acid, okay. So here this will be acid, okay, this will be acid. So what will happen here is they will have tendency to lose the H plus, okay. So what will happen when during the losing of H plus, there is possibility of having NH3. Okay, there is possibility of having NH3 because why? One H is gone. Okay, they will form back this. Okay, so when Cl and H, okay, Cl and H, in this case, most likely you are going to get calcium chloride, okay, and then maybe water. Okay, this is going to be the equation. So definitely ammonia gas is going to be produced, not nitrogen gas, yeah. Definitely not going to be nitrogen gas. So the answer is going to be identity of M is ammonia. Okay, let's look at this question 25. Okay, so two nitrates decompose on heating according to the equation shown. So they give you these two equations, okay, and then they use only 1 mole, okay, then they pass through the gases through sodium hydroxide. So we need to also find out, okay, when you pass this gas through sodium hydroxide, which are the gases that will react with sodium hydroxide. Okay, we know that, okay, sodium hydroxide can react with NO2. Why? Because it is an acidic gas. Sodium hydroxide is base. So this will be reacting, okay, it will not be collected, okay. So the only one will be collected over here is going to be O2 only, Okay, so if I use 1 mole over here, okay, 2, okay, to 4, supposed to be, okay, double over here, and then this one supposed to be half of it. But the one that is going to be collected is only O2 because this one will react. So in this case, you only collect 0.5 mole of O2. Okay, here, okay, the gas, there are 2 types of gas, okay, but we know that when you react with sodium hydroxide, this is unreactive, yeah, so they will not react. O2 do not react with sodium hydroxide. It means that both of these gases will be collected. So if I use 1 mole over here, because 2 to 2, 1 mole of nitrogen will be collected, and then 2 to 1, so here should be 0.5 mole of oxygen will be collected. So in total here, you will get 1 mole of N2, and you will get 0.5 moles of O2. And we know that, okay, 1 mole will have 24 dm cube, okay, volume. So half should be 12 dm cube. So here 1 mole is 24 dm cube, half will be 12 dm cube. In total, you are going to get this one, you will collect 36 dm cube. So in this case, greater volume collected is coming from ammonium nitrate. So ammonium nitrate, greater volume will be collected. Okay. So now we are going to look into the percentage of loss of mass. Okay. So percentage loss of mass. Okay. We also look at the mass of the gas that is given out. Okay. So in this case, because once you have this particular mass from here, they will lose the mass because the gas will go out. Okay, so here, okay, I am getting for PbNO3, okay, I am going to lose, okay, 2 moles of NO2 and 0.5 moles of O2. And then for NH4, NO3, I am losing 1 mole of N2, 0.5 moles of O2. Okay, so I find out what is the mass first. Okay, so nitrogen is going to be 14. Okay, oxygen is 16. 16 times 2 is going to be 32. 2 moles, okay, times 2. So that's going to be 2 times 46. So that's going to be 92 grams is being lost. Okay. And then 0.5 moles of O2, okay, we know that 0.5 O2 is 16 plus 16, 32, so you will get 16 grams. In total, you will lose, okay, 92 plus 16, so you will lose 108 grams. But if you want the percentage, okay, percentage is going to be 108 grams divided by the MR of PbNO3, yeah? So what is the MR just now? We calculated. Or you want to calculate, please calculate now. Then we need to times 100%. Okay, while you do that, this one, 1 mole of nitrogen, 14 plus 14, 28 gram. 32 times half, so 16 gram. This is going to be 44 gram. Percentage 44 divided by, okay, the MR of the mass of this times 100%. Okay, Jaden? 600. Okay, in percentage, how many percentage? Are you sure? No, I don't think so, yeah? 331, correct. 331, then you will get 30 something. Can you calculate? Was it 35, Harry? 32.6%. Okay. Now, here, I need the MR of this. Ammonium nitrate. Anyways, okay, you calculate the MR, okay, of this, okay, then MR change into gram, okay, because it's for 1 mole, yeah, they use 1 mole and they use 1 mole, okay, how many gram? Then you times by 100%. What is the percentage, Harry? 55. Okay, so you compare, okay, this one have higher percentage over here, so ammonium nitrate will be greater loss of mass. So that's why it's going to be A, yeah. So let's go on, okay, 26, okay. Organic compound X has empirical formula of C2H4. Now, compound X is reduced by LiAlH4, but not by NaBH4. Okay, if you remember this, it's a strong reducing agent. It means it's applying to carboxylic acid. Okay, carboxylic acid must use LiAlH4, cannot use NaBH4. Okay, what is the compound? Okay, so you see, maybe this, maybe this. Okay, so we know that C2H4O, okay, if you put ethanoic acid, okay, ethanoic acid is CH3COOH, you will get C2H4O2. Can you change this into this? Okay, no. Okay, because if you divide by 2, you will get 1, 2, 1. Okay, you will not get the same empirical formula. Okay, now if you are using butanoic acid, 4 carbon. Okay, this is butanoic acid. C4 hydrogen 1, 2, 3, 4, 5, 6, 7, 8. Okay, then oxygen, there's going to be 2. Okay, you divide everything by 2, you will get 2, 4, 1. 2, 4, 1. So the answer is D. Okay, you can convert back to the empirical formula. Okay, so 26, the answer is D. Now 27, what is the mechanism of the reaction? Okay, hydrogen cyanide with propanol is a giveaway. Okay, nucleophilic addition. Okay, all carbonyl compound will undergo nucleophilic addition. Okay, what is the catalyst for this reaction? KCN. Okay, KCN. Now, which compound, okay, may be synthesized from alkene, okay, with this formula, okay, with an addition reaction. So we want 4 carbon, okay, 4 carbon, and then we want the 4 carbon alkene, okay, to go through a reaction, addition reaction. Okay, so if you have, okay, let's say 4 carbon, okay, and then you have double bond here. Okay, if I react with Br2, possible to get 1,1, okay, dibromobutane, possible. Okay, but sorry, cannot get 1,1 dibromobutane, okay, because that's free radical substitution at the same carbon. Yeah, supposed to be 1,2 dibromobutane. Okay, is it possible to get from 1,3 dibromobutane? No. Okay, can you get propane? Propane, and then methyl will be CH3 here. Okay, let's say it means in the beginning itself they started with something like this. So maybe the double bond is here. Okay, if you have the double bond here. So 1, 3, okay, even though the Br comes here, it's supposed to go here and here. Okay, it will still be 1, 2. Okay, so cannot be here. So the answer is going to be B. 29. Now this compound, okay, undergoes addition polymerization. For addition polymerization, we focus only on the carbon-carbon double bond. Okay, so all these, okay, are others. Okay, are others. Okay, so here, okay, you have CH2. You bring it over here. The double bond becomes single bond. Open one arm. Okay, this one carbon. Open another arm. This one will become C triple bond N. This one will be CO2CH3. Close. Okay, so check which one gives you that. Okay, CH2, C, this one. Okay, so the answer is C. Okay, it matches. Okay. Now 30. Compound T is tested with 3 regions. Okay, and the results are shown. Now, when you have this, so this one is carbonyl compound. Okay, so it can be aldehyde, it can be ketone. Okay, but you see Fehling solution, no reaction, it means it must be ketone. Okay, ketone, acidified, okay, acidified K2Cr2, no reaction because ketone cannot be further oxidized. So the answer must be a ketone, definitely wrong. Okay, aldehyde. Okay, this one is alcohol, definitely wrong. Okay. So this one CH3, CHOH, COCH3, possible. Okay, possible. Here CH3, but do remember they say cannot be oxidized. So here this is going to be R and R secondary alcohol. Secondary alcohol can be oxidized. Okay, secondary alcohol can be oxidized to ketone. So this one also cannot be the answer, the C. Okay, D, CH3, CH3, H, C double bond O, CH3. So this is ketone definitely. So our answer is D. Okay, 30 is D. Now next question. Region X is added, okay, separately to this compound and this compound. Okay, the visible results are different. Okay, so let's check. Butan, okay, 1 all, so OH is here. 2 methyl, okay, 2 methyl, so CH3 is here. Then butan 2 all, okay, 2 all. 3, this is 2, then this is 3, CH3. So between these two, okay, these two. Now, alcohol do react with sodium, so they say the results are different. Alcohol do react with PCl5, okay, cannot be like that. What kind of alcohol over here? Okay, this is a primary alcohol, okay. Here, this is going to be a secondary alcohol, but do remember, primary alcohol and secondary alcohol, they can be oxidized. So the what you see is going to be purple color will be decolorized, so no. But when you test with alkaline I2, okay, you see alcohol that has, okay, carbon OH must have CH3, must have H, must have R group, will give you a positive result. Okay, so here you can see the second one, there is H, there is CH3, there is a R group here. This can be giving you a positive result. But here there's 2 H and 1 R, not a positive result. So in this case the answer is going to be B. Okay, we'll do this one as our last one. Okay, so here, okay, compound Y, okay, is going to be hydrolyzed, okay, by warm aqueous silver nitrate, okay, to form a precipitate that is soluble in dilute aqueous ammonia. Now here, okay, when you react, okay, always remember, okay, when you react with silver nitrate, okay, when you use dilute ammonia, okay, we know that if you are using, let's say the precipitate is AgCl, AgBr, AgI. If you are using ammonia, dilute ammonia, and concentrated ammonia, okay, this color precipitate is white, cream, and yellow. Now, if you use dilute ammonia, silver chloride, the white precipitate will dissolve. Of course, this one will dissolve also. This cream precipitate will not dissolve at dilute, they will dissolve at concentrated. yellow precipitate will not dissolve, Okay, so in this case, they ask the one that will dissolve in dilute ammonia itself. It means must have chlorine. Okay, therefore, this and this will not be the answer. Okay, so we know that between here and here. But they say that compound Y undergoes elimination reaction. Now, when something can actually undergo elimination reaction, okay, you see here, okay, when I have carbon over here, okay, so I have 4 carbon, okay, 4 carbon, and then there is Cl, and we know that there is a hydrogen over here, okay, so elimination can happen, okay. But if you follow this one, okay, there are total 3 carbon here, 1, 2, 3, and then carbon number 2 has CH3, so CH3, carbon number 2 has CH3 here, and this contains Cl, okay. Do remember Cl, okay, if you look at the left, okay, there's no hydrogen directly attached, okay, it's attached to carbon, okay, so elimination cannot happen. Okay, there is hydrogen here, there is hydrogen here. Okay, but this carbon is attached to CH3. So if like earlier, if I have CH3 here, no reaction can happen. Okay, but the reaction can still happen because there is another hydrogen at the top. It means the Cl, okay, I can actually react like this. Okay, but in this case, even though it comes over here, there is no hydrogen. Okay, therefore, okay, this one does not undergo elimination reaction. The one that will undergo elimination reaction is going to be C. To question number 33. So propan 2-ol can be converted into 2-chloropropane, okay, using region M and followed by region N. Okay, so propan 2-ol, okay, we want to convert into propan, okay, 2-chloro. Okay, so you want to do this, okay, using region M followed by region N. Okay, so first of all, okay, they are using, definitely have to use Cl, okay, but this one probably, yeah. So first region, okay, that they are going to use is going to be definitely going to be the elimination reaction. Okay, they need to use concentrated acid. Okay, concentrated acid. So they need to remove this OH. Okay, so that they can get C like this. Okay, after that they need to add the Cl2. Okay, they need to add the Cl. Not Cl2, okay, because it's chloro, okay, they need to add HCl. Okay, so HCl, H will go here and Cl will come over here. Okay, so this is going to be the answer C. Okay, 33 is C. Now 34, okay, skeletal formula of 4 organic compounds are shown. Which 2 compounds, when separately heated with dilute sulfuric acid, okay, produce propanoic acid as one of the product. Okay, so this is going to be dilute sulfuric acid, okay, when you are heating them up. Okay, so when we heat up, okay, so for example here, this is going to be aldehyde. Okay, aldehyde. This is going to be ester. This is going to be nitrile. This is going to be ester. Okay, so when you heat up with dilute sulfuric acid, okay, heat up with dilute sulfuric acid, okay, most probably, okay, we are breaking the ester, yeah. So when you break the ester, okay, break the ester, okay, you have H and OH here. Okay, you have H and OH here. So here, if we are looking into propanoic acid, okay, 1, 2, 3, okay, there is going to be propanol. Okay, so not propanoic acid here. So here it's going to be 1, 2, 3. Propanoic acid is possible. So 2, yes. Okay, 2 will give you propanoic acid. And then heated with dilute sulfuric acid. Okay, dilute sulfuric acid, aldehyde, nitrile. Okay, Dilute sulfuric acid, okay, is going to be similar, okay, because this nitrile RCN, okay, when you dilute means it contains water, okay. If you have the H plus there, what is going to happen? You are going to get the RCOOH, okay, and then plus NH, okay, NH4 plus, yeah. So you can actually get that, okay. So this one, okay, basically you are going to get a reaction here, okay, where you are going to get the carboxylic acid. So 1, 2, 3 carbon. So the answer is going to be 2 and 3, okay, C. 34, the answer is C, okay. Now 35, 1 chloro 2 methyl propane, okay, 1 chloro 2 methyl propane. So propane, methyl, and then chloro. So butane, methyl over here, okay, position number 2, then bromo. React separately with silver nitrate. So if you react silver nitrate, we know that this is going to give you a white precipitate. This is going to give you a cream precipitate. Both reaction proceed with nucleophilic substitution and precipitate is formed. The time taken, okay, is T1. The time taken for this is T2. Okay, so this one is going to be T1. This is T2, time taken. Now, which mechanism? Okay, let's find out which mechanism is that. Okay, if you look at the carbon attached to chlorine over here, this is going to be one R group, the rest are H. So this is going to be primary halogenal alkane. This carbon attached over here, there is one R group, another R group, another R group. Therefore, this is going to be tertiary halogenal alkane. Okay, so we know that SN1, okay, SN2, okay, SN1, okay, will actually go for tertiary. Okay, so this is SN1. SN2 will go for primary. Okay, SN2 over here. Okay, so here, okay, they say that, okay, the main reaction is there. Time taken, okay, for the precipitate to appear, okay, related to the time taken, okay, it depends on the CL and BR. We know that the CL is smaller, BR is bigger. Okay, compared to CL, BR, okay, can be easily broken, okay, because it has more bond length and it has less bond energy. Okay, therefore, because of that, okay, the answer will be the time taken, okay, for the precipitate to appear for BR will be the T2, okay, is going to be shorter time. Okay, T2 will be shorter, T1 will be more, and because of the chloro, okay, we need to follow the SN2. Okay, so this mechanism, so the answer is going to be B. Now, for the next question, okay, the diagram shows the structure of progesterone. Okay, you can see over here, okay, which statement is actually about that is correct. Okay, so if we look over here, okay, they have mentioned that, okay, one molecule is either 21 or 19. We can calculate now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, where's another one? Yeah, let me calculate again. Okay, so let's calculate again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's C21. Okay, so we can ignore the C19 over there. And then another thing is we need to check how many chiral carbon are there. Okay, in order to check for the chiral carbon, we need to analyze each one of them. Okay, so each carbon, okay, must have 4 bonds. So we will ignore this, ignore the one that has double bond. Okay, then we will ignore the one that has 2 hydrogens. Okay, we will ignore that first. 2 hydrogens, ignore. Okay, ignore the 2 hydrogens. This one also will be ignored, 3 hydrogens. and then we will analyze this one R group, another R group, another R group, another R group, okay, different. So this is going to be one of it. Okay, there is one hydrogen, different, left and right, and this is going to be another chiral center. Okay, there's hydrogen, left and right, different. So here is going to be one more. Okay, there's hydrogen, left and right, different. Okay, so one more. Okay, this is going to be one more. Okay, and this is hydrogen, one more. So if you look over here, there are a total of 6 chiral center carbon atoms. So therefore the answer is going to be D. Okay, let's look at question number 37. Okay, a molecule of hexane can be cracked in a number of different ways. Okay, 3 molecules compounds are listed over here. Which compounds are found in mixture of products from cracking hexane molecules? Okay, so you have C6H H double plus 2, so it's 14. Okay, so we want, okay, which compound. So if let's say you have, okay, all these, which compound mixture of products from cracking, yeah, mixture of products. Okay, can we have all? Okay, over here, okay, let's check. Okay, 9, okay, 9 plus 3 is going to be, that's already 12. I don't think so. Okay, let's check 1 and 2. Okay, 1 and 2 is going to be C7. Okay, 1 and 3 is going to be 8. Okay, 2 and 3 is already 9. So I think they are not talking about, okay, just from hexane. Okay, it means they are talking about what you can obtain. Okay, so what are the possibilities, okay, you can actually obtain, okay, the products that you can obtain when they break. Okay, when they break. So in this case, definitely, okay, when they break, okay, they cannot break, let's say for example C3, yeah, definitely possible. Okay, C3H6, okay, so that is going to be double plus 2, so it's going to be alkane. Okay, possible. So it's propane. Okay, propane. And here you are going to get, okay, if you have propane, okay, if you have C3H6 H8, you can have, okay, C3H 14, so 6. Okay, possible. Okay, this is possible. So if I have C6H14, okay, to give you C4H8, okay, so I can still have C2H H6, okay, which is possible. Okay, it's going to be ethane. Okay, you will get ethane, so this one is also possible. Now C6H14, okay, if I break into C5H12, I will get, okay, 1 carbon. Okay, hydrogen will become only 2 hydrogen, CH2. In this case, okay, there is going to be a problem because we cannot get CH2. Okay, CH2, each carbon must have at least 4 bonds. Okay, this is not possible. Okay, this is not possible. So the answer is going to be B. Now, so 38, the diagram shows the structure of 2 isomeric dicarboxylic acid, X and Y. Okay, so you have this and this. Okay, when they say isomeric, okay, this R group and this R group, so this one is cis. Okay, and then we have this one and this one, this is going to be trans. Okay, now X can be reduced, okay, to compound P, okay, with the empirical formula of this, okay, and Y can be reduced to compound Q with the empirical formula of this. Okay, which statement is correct? Okay, let's check first. X is a cis isomer. Okay, so this one trans isomer, wrong. Yeah. Now, then compound P and Q are identical. Okay, let's check. Okay, let's check. Okay, when we reduce, okay, okay, to compound something, yeah. So when I reduce carboxylic acid, okay, carboxylic acid, we can reduce to become aldehyde. Okay, we can also reduce to become alcohol also. Okay, so they mention C2H5O. Okay, let's say X, okay, reduced to become aldehyde. Okay, if they reduce to become aldehyde, C double bond C, this one will be this, then H, this will stay, double bond O, this one will be H, this one H. Okay, so this will be C4H 1 2 3 4, and then O2. Okay, so this one there is, okay, 4H, so definitely cannot be this because C2H5O. Okay, so not that. Okay, it means they are not reduced to aldehyde. Yeah, so they are going to be reduced to become alcohol. Okay, primary alcohol. Okay, so what happens? C double bond C, so this one will be OH, this one H, and this one will remain as H, C, and then this one will be OH, H, and this one will be H. So this one will be C4. How many hydrogen? 1 2 3 4. Oh, sorry, 1 2 3 4 5 6 7 8. And then oxygen, there's 2. Okay, divide that. Okay, empirical formula. 1 2 3 4 C4. Hydrogen 1 2 3 4 5 6 7 8. Oxygen, there's 2. Okay, if I divide by 2, C2H4O. Where do I get H5? Okay, if they are reduced to become aldehyde, get this 1 2 3 4, 1 2 3 4, and O2s. We divide C2H2O. Okay, I'm not getting this. Okay, so compound P and Q are identical. Compound P and Q are isomers to each other. Normally, yeah, I think let's straight away assume here, okay, when they have the same, okay, we know that both of them, okay, both of them when they reduce is carboxylic acid, whatever that they are going to be reduced to, okay, let it be primary alcohol, okay, or what, okay, they are going to be the same, okay, they are going to be identical, okay, they are going to be identical. In this case, isomer to each other, not really, okay. I think most likely I will go for A over here, okay. So definitely going to be identical, okay. It's going to be the same product, okay. But when I calculate, I'm not getting it, okay. Probably don't know whether I made a mistake over here. Supposed to be, okay, when you reduce carboxylic acid, you will get primary alcohol, okay. So I have primary alcohol, but just when I calculate, okay, I'm not getting the same empirical formula. 1 2 3 4 1 2 3 4 5 6 7 8, okay, 8 O2. So when we divide by 2, C2H4O. Okay, I think something is wrong here, yeah. But anyways, it's A, yeah, it's A. Now 39. What is the total number, okay, of sp3 hybridized atomic orbitals used in the bonding of but2-in? Now, this is but2-in. So sp3, okay, sp3 means, okay, they have 1s, okay, and 3 p orbitals, making total 4 orbitals, okay, 4 orbitals. So they must have 4 bonding without the pi bond, yeah. So this one is 4 bonding, yes. This is going to be, okay, they have 1 2 3, so this is sp2, okay, this is also sp2. So this one is going to be 1 2 3, so sp3, okay. So what is the total number of sp3 hybridized atomic orbitals used in the bonding. Okay, atomic orbitals used in the bonding is 1. Okay, they are bonded to hydrogen also. Okay, these are also bond over here. They are bonded over here. Okay, so it means if I tell how many, 1 over here, 2 over here, 3 over here, 4 over here, and then 5, 6, 7, 8. Okay, so the answer should be D. Okay, 8 orbitals. Now 40. Compound L contains carbon atoms. Okay, it is analyzed using mass spectrometer. The table shows abundance of only 2 peaks, okay, recorded with M over E greater than 127. Okay, 2 peaks. Okay. How many carbon atoms, okay, are present in one molecule of compound L? So in this case, this is going to be 128, and this one I assume because it's n plus 1, yeah, 129. So we are going to use this, they say only 2 peaks, okay, okay. So in this case, okay, we are going to use the formula. Number of carbons is going to be 100, okay, divided by 1.1 times the abundance of this n plus 1, so 5.5 divided by 50, okay, and then you will get, okay, 550, and then 51.1, 55, then it's going to be total 10. Okay, so the answer is going to be D. Yeah, so that's it. Okay, we are done. Okay.